Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Artem Kroupenev, Head of Strategy for Augury. Augury uses AI to detect machine failures before they occur by empowering the largest process manufacturers to integrate AI into their daily operations. In this talk, we discussed how AI co-pilots are transforming the factory floor by guiding maintenance, quality, and production decisions with highly accurate diagnostics. We also explored the impact of GPT-4 and other large language models on how manufacturers make use of unstructured information and build more convenient user interfaces. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT strategy, research, or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you. Artem, thanks for joining me on the podcast today.
Hey, nice to be here. Thanks for inviting me.
Yeah, this is going to be an exciting one. So I had your CEO on about a year ago. And so I think it's not necessary to kind of rehash a deep dive into what Augury is doing. And that gives us a bit of the luxury to focus on one of the topics that you're also taking a leading role in, which is bringing AI into the manufacturing environment. So really looking forward to this conversation. But let's still give folks a bit of a refresher on what Augury does. Can you give us maybe the 2-minute, 3-minute version of what's your value proposition, what solutions are you providing, and who you're providing them to?
Absolutely. So Augury is today a market leader in machine health and now going into what we call process health. And it's part of the production health category. So when you think about manufacturing or industrial operations, today we make sure industrial machines don't fail. And we do that through AI as well as IoT applications. And when we talk about process health, that's making sure that your factories can produce product sustainably, highest possible quality, at the lowest possible cost, etc., and also applying AI technologies to be able to do that. And then there's other things that we're starting to do, which kind of go into the wider category of helping manufacturers start managing the network of their plants and their operations. So we can delve into that as we talk. But in its essence, that's what Augury does. And we work with over 100 different manufacturers and industrial companies across segments like chemicals and food and beverage, and plastics and building products like cement and wood and metals, a number of other materials. That we recently ventured into the energy space, the oil and gas space, with a partner called Baker Hughes. And that happened over the past couple of years. So we kind of like to say that we make sure that manufacturers of medicines and beer and snacks and things they use every day keep doing that and do that sustainably and a higher efficiency. And you're welcome.
Yeah, perfect. Thanks, Artem. And yourself. So what is your role at the company?
So I had strategy at Augury. I joined Augury some time ago, over 7 years ago, when the company was about 3 or 4 years old. And I joined Sar Yoskovitz, who's the CEO, co-founder, and Gal Shaul, who's CTO, chief product as well as co-founder, and the early stage team in order to help build out the first product, bring that product to product market fit, and then develop beyond that. So kind of my role evolved from product to go to market to partnerships, ecosystems, corporate development for the company, and kind of making sure that we have a solid strategy and a good vision for how we take that forward. We just keep building. Part of that role has been, helping navigate that stage that we're in right now, which is hyper growth. Just very, very rapid growth across markets, across segments. So that's been very exciting for me.
Yeah, absolutely. No, it's great. Yeah, and you're coming from perspective where you were VP of or head of customer development, VP of products. So you have these different perspectives before moving into the strategy role, which I think will be very useful for this conversation. Maybe let's start at a higher level and then go deeper. If we talk about AI in the factory, I'm interested in hearing how you think through this. For me, there seem to be the traditional way of, we have data coming off machines. We use machine learning to process that data and have some sort of outcome of that process that we make decisions on. And then we have this newer development of GPT. And then you start to look at, okay, to what extent can we digitalize the knowledge? And we have all these 55-year-old experts that have been working in the factory for 15 years. They're going to retire. How do we put their brains in a machine? And, and that's quite a different process. And also the front end interaction, right, that people might have with that machine would be quite different. That's a little bit my layman's way of thinking through this, but how would you at a high level think through, how we apply AI or machine learning to the manufacturing environment?
I think when we talk about AI, it's not one thing, it's a number of different things. So we can break that down. But ultimately, these technologies require a slightly different thinking than we've had traditionally in the past, through, let's say, the earlier industrial revolutions, where we would think about taking what exists today, the processes that we have, and automating them, right? Automating certain tasks or digitizing those tasks, right? So moving from analog to digital to make them faster, better, more, better repeated, and so forth. Here, we have the opportunity to create, a kind of like a partner to think through problems, to make better decisions, to expand the scope of how we think, how we do, and even how we sometimes imagine things being, which is a bit of an abstract concept. But I think that thinking about AI just in terms of pure automation does it some disservice. And the way I think about it, the way we think about it is, we help apply these technologies not to a task and not to just technical aspects like data, right? Or some part of what you do or a process, right? We're thinking about applying this technology to a function. So a function like reliability and maintenance, or a function like process engineering or, manufacturing. Within those functions, we really are making sure that what is it that people in these roles, what are they tasked to do? And what are their goals and ambitions? Or what do they actually want to do and need to do? And how can we help do that a lot better, more effectively? But also, how can we expand that in a way that makes those roles and functions just a lot better and a lot more productive? And so that perspective helped us kind of really hone in and focus on how do we build our products? How do we approach this industry in these types of solutions? And we started with reliability and maintenance, right? How can we make sure that those functions are a lot better and that the key problems that they have today, we make sure that we to eliminate them as much as possible, right? So that's kind of the holistic approach. It does come down to both a set of tool, but also a different way of working. For instance, when you think about our product around machine health can accurately predict machine malfunctions and really hone in on a specific issue, the specific component of a machine with over 99.9% accuracy, right? And it can also tell you what's the severity, so how much time do you have to fix it. That flips the traditional approach to reliability and maintenance kind of on its head, right? Whereas you had time-based approaches and you would go and say, well, I don't really know when this machine is going to fail, but I'll make sure to maintain it in certain time intervals to reduce the risk of that failure. Now, the first thing that you do is you monitor that machine and you deploy AI to make sure that you understand exactly what's happening. And based on that, you create your maintenance and reliability strategy. So that changes the perspective, and eventually that will change the way they teach these disciplines in university, right? Or at school, because it's just such a game changer in terms of how you approach it. And we're doing the same for process engineering and some other kind of functions that we have. So I think that's the difference in approach in terms of how we think about it. The other aspect of it is, and the difference of approaches, you have to take into account how those functions interact between themselves with each other, right? We see a lot of silos, hierarchies that are, exist in the manufacturing and industrial space. And for a good reason, traditionally, you had to compartmentalize these roles in order to be able to perform some of these roles and functions effectively. In the world where you have access to insights almost in real time, in many cases in real time, exactly what's happening with your equipment, with your processes, with your scheduling, with your potentially large parts of your supply chain. In that case, all the different functions actually need to look at the same thing, the same data, make decisions based on that data, those insights, and also work towards the same goals. Right? You can no longer incentivize people to work on different things as part kind of cogs within this mechanical structure, this machine. but rather they have to act as a team and work very, very tight iterations in order to share learnings, understand what's happening, and then potentially make decisions that are strategic for the business at their level in order to be able to move faster, be a lot more agile, and meet demand ultimately, right? And make those changes. I think that is the other part that AI technologies have initiated within the space, is that we're kind of changing the nature of how we manufacture things by changing how we think about these functions and roles, and by thinking differently about how they interact with each other.
Okay. Let me present a specific case so that we can kind of make this as tangible as possible. So let's say we have a chemical manufacturer in a commodity industry. Let's say it's one of those industries where if one factory globally goes down, it starts to impact supply, and then pricing starts to fluctuate globally and so forth. So it's one of those situations. There's some kind of outage in a piece of equipment, and then you have, as you said, these different functions that have to react. So you have maintenance reacting, you also have forecasting reacting, you might have salespeople, you might have supply chain people who all have to react to the situation and make decisions around it. And let's say the baseline AI that you've probably been working on over the past number of years is processing of the machine data so that at least the maintenance people can look at it and have a sense of what's going on. The other people might look at that data and not be able to make sense of it, but they know that something's wrong, right? Different people have a different level of understanding. And so I would say that is very important. And that's kind of the first layer of, okay, there's a machine that has a problem and we have some sense of what the problem is. Then you have all of these other decisions that need to get made. What is the likelihood of us being able to fix this within 1 hour, within 1 day, within 1 week? What are the impacts on supply chain, et cetera? So you have all these other decisions that are made. To what extent are we at a point today where Augury, or maybe the broader AI ecosystem, is starting to also impact these higher level decisions that people would be making, whether, perhaps not automating them in any case, but providing some kind of guidance or insight to allow people to make more confident, quicker decisions?
Yeah, absolutely. I think one of our customers put this very, very well. He said, ultimately, I would like you, meaning Augury, to help me understand whether it's better for me to make this product in this plant or in that plant, based on the health of my equipment that's tuned to specifically what I'm producing, the health of the materials that I have, the health of the production processes that I have, and also the good understanding of how my team might react to it. So not just reacting quicker to a machine failure in a plant in terms of the supply chain, but being proactive about planning based on a good understanding how will predictively your plants react to a change, introduction, a new product, some kind of systemic change that you have. That is the real insight and kind of intelligence that we're aiming for. And also to be able to execute in that autonomous way. So not just a lot of automation in terms of running those processes, but also having parts of the process controlled in a way that those decisions can actually be made and implemented in a very quick time. So let's say if you have an extrusion process or some kind of production line process, that process can automatically adjust the send points and recenter line based on the new product that you're introducing, taking into account the reliability impact, taking into account the maintenance impact, taking into account the materials and so forth. That's kind of I wouldn't call it the holy grail, but that's the next stage in evolution around being predictive capabilities, predictive production and capacity. Where we are today on this journey is that we kind of think about this as a 3-stage evolution, right? 3 levels. The first level is, we call it predictability or stability, right? Where you make sure your plants are humming. Your machines no longer fail unexpectedly or fail at very much lower rates. And you have good predictability around, if I'm running this process, that's my center line and so forth, and I can run it very effectively. The second piece is, we call that agility, right? So you can essentially start introducing a new product, and your stops, your changeovers, the disruption to the system from a change becomes a lot lower because you can adjust much quicker. And then the last stage, or the kind of that next stage, becomes autonomy, where not only do you adjust quickly, but you can also predictively say, here, is it better for me to do it here versus there? What will be the impact? What will be the effect? And you can roll it out a lot more seamlessly than you can today. In some cases, introduction of a new product takes a year, months for some manufacturers. Can we cut that down into days, right? And to be able, accurately to predict what will happen. So that's kind of where we're thinking about in terms of the evolution and levels of autonomy, if you will, within factories.
And so what does this mean in terms of integration of systems? Because I guess at the lower, let's say first tier, you can almost look at a machine or a production line and say, okay, this machine flash the red light, send an alert on an app to a group of people, and it's fairly isolated in terms of the alert and the impact. And as you move down that progression that you just outlined, then you start to look and say, okay, well, now we need information from MES and maybe two-way communication. We need to start automating processes. We might need to be sending alerts not just to this group of people, but to multiple other functions within the organization. And once we move into that third tier, also potentially automating important decisions. And then you want to make sure that you really are doing those in the right way, and you have safeguards, and you have memos going out. Why are we making this, et cetera? So you start to get into this highly integrated system. So where are you today on this? And then what does that journey look like also from the perspective of the manufacturer? Because of course, a lot of these plants are sitting on 20-year-old, maybe 40-year-old equipment and 20-year-old IT systems.
Yeah, absolutely. The level of complexity in the industrial world is, I would say, an order of magnitude higher than it is in applications like autonomous driving, which are already pretty complex because you have so many different ways of doing things, let's say running a process, so many different types of pieces of equipment, different environments, different cultures, and also vastly varying levels of maturity in terms of how you do it. So the level of standardization that you have in autonomous driving, you have very similar road signs that have been agreed upon across most of the world. In manufacturing, there are today competing systems into how do you approach, for instance, just-in-time or agile manufacturing that have not been fully agreed upon, and there are various flavors of that. So there's a lot of complexity when you get to that level of really understanding and customization. I think that's where a lot of companies that provide services around AI, not products like Augury, but services around there, that's where the limitations come in, because there's a lot of unique kind of snowflake solutions for that specific plant, that specific sub-process, that specific instance that doesn't really scale across. And the way we approach this is by looking at use cases, and again, as I said, functions, right? So that serve specific functions within manufacturing, so people ultimately, really, and not just processes that are replicable and kind of lend themselves really well to amplification with AI. And when we mentioned co-pilots, right? Or maybe we haven't, but that's a term that I want to introduce. Can we build a co-pilot for reliability? What does that entail? That entails the ability to essentially predict machine failures across a vast array of equipment. Which machines are similar in that sense that we can actually do that? Well, rotating equipment is something that we started with, and then we're adding additional types of equipment as we go along, right? Different types of physical movement, linear movement, right? That's not just rotating and so forth. That is kind of our approach is we start with a large use case that kind of lends itself well, and then we expand that use case and create more and more coverage within that. The same goes for process, and the same will go for the next 2 or 3 or 4 use cases that we have in our plan and our strategy. Once we do that fairly effectively and we provide value at each level of those use cases, the correlation between them becomes very, very clear and apparent. And we already are starting to do that between machine health and process health by helping identify which machines are contributing to quality issues, for instance. And some of them do, and in some cases, a lot of them do, right? So starting to bridge those gaps, but we are bridging those gaps in a very tangible, very actionable manner. Not just let's take all the data possible and try to glean insights from it. Rather, how can we bring these two functions together around the most critical part of what they do and build those bridges between them? But first, we have to make sure that those functions are augmented with, these AI co-pilots, these new capabilities that AI brings. So I hope that approach, that structure makes sense.
Yeah. It makes a lot of sense. So you don't go in and say, let's build a smart factory. You go in and say, let's focus on some high value problems to solve that are initially isolated maybe to one function, and then let's expand from there and start to connect these data points. And I guess as you go through that, you start to say, okay, for this particular application to solve this problem, we're going to now need to connect to your quality assurance system, or you start to build out those integrations. My assumption is to start with that Augury was working with a lot of machine data that's highly structured, and that as you start to expand and provide value to address these other use cases and challenges, you start to potentially move into cases where you say, well, we have root cause analysis data in PDFs that have been written about every problem that's happened over the past 20 years. And that data would be quite valuable, but it's in PDFs. We have BOMs, we have specifications, we have all sorts of information that would help us to better understand the problem, but it's not coming off a machine in a nice structured way. To what extent are you working with this less structured information today in your deployments?
One way that we think about it is that if you look at a factory, manufacturing floor, a lot of the things are interconnected by design or through routines or through some other variation just by nature of how it operates. But you can also see that some of the key issues, the more critical issues that you can really unblock for a factory, they coalesce around a few centers, right? A few machine centers or a few ways of doing things and so forth. So the problems tend to cluster and they're not completely dispersed. So making the connection between those is really driven by value. What is needed and necessary to unblock in that factor. The other piece that you mentioned, how do we deal with gaps in data or data that's kind of legacy or exists in various places, especially if we're talking about the history of maintenance or the history of running a process and so forth. The way we approach it is that, well, do we need it? Where's the actual ground truth? Where's the proof? For us on the machine health side, it's actually in the current state of the machine health condition, right? So we provide our own hardware to get the right quality data and you get it properly standardized. And so we don't need historical understanding of what happened with that machine. It's almost irrelevant because we can tell you the current state going forward. But then the process side, there's some need for historical data and understanding. How was this process running before to understand what's the optimal way of running this process? What matters is if Augury provides an insight around how to better run that process. And when we implement it, it actually improves the process and it works. That's the majority of the proof and value that you need. I'm not saying all the historical data or how the previous processes are not relevant at all. That there's a lot of knowledge that goes into that you can get a lot of insights out of. But we focus on the actual operational side of the process and is it being improved in a tangible sense. And based on that, then you can improve your routines, you can train people, but you kind of become, those insights and capabilities become ingrained as a natural part of how you operate. And it's actually very difficult to go back for somebody who's had the experience with a technology product like Augury to go back to the way it was before because they really vividly understand that we're running blind, right? And then you see the evolution kind of adjusting the routines, the maintenance practices, the process recipes, kind of start adjusting and taking into account the insights that Augury provides.
Okay, makes sense, right? So yeah, on the machine health, that makes sense. And then I guess on the process side, you're creating these feedback loops with every decision, every recommendation that the system makes. And so that provides
absolutely, yeah,
information to optimize. One of the reasons I'm kind of poking at this question here, and I'm really curious on whether you think this is interesting or not at all, but obviously the world is going a little bit crazy right now because of the launch of GPT-4. And there's been this whole world of machine learning around production data that probably isn't actually impacted too much, right? That was basically already working quite well for the problems that it was addressing. These large language models are basically addressing this other set of information, which is kind of messy human speech, images and so forth, and making sense of that. And the reason I was looking at, these root cause, because there's this whole set of data that is human speech, right? And it's written down somewhere. Or it's even in somebody's, coming back to this, the 55-year-old maintenance engineer, it's in somebody's brain. Hypothetically, that would be valuable. And we haven't, I'd say, generally tried to address this before, right? So if there's a root cause analysis, somebody might go and look through some old reports. That's a very time-consumptive problem. So you're only going to do that if you really have to, or, a time-consumptive way to solve the problem. And so I'm curious from Augus's perspective, and also from your strategic perspective at the company, has this impacted how you think about the way that you solve problems in the future, the ability to work with human language in a way that maybe 12 months ago didn't seem as feasible?
Yeah, absolutely. And we're actually developing a number of things in that area. So for us, we're AI company. So our customers look to us for answers when a kind of a new wave of technology comes in. So obviously we very early on have been diving into and thinking about what is the impact of this, what are the applications, the use cases, and so forth. The way I think about it is that we have narrow AI, right? Or let's call it AI that's kind of domain specific, which is AI that helps you figure out the health of the equipment, takes certain signals that we can't even, for us people, it's very difficult to analyze and understand them, right? But it makes a lot of sense with an AI application, process data and so forth. And you can take that to other areas of the enterprise, or financial data, transactions, ERP data, and supply chain data, and so forth, right? So that is kind of a narrow domain-specific AI application that requires a level of, in some cases, physics, optimization, domain expertise to be baked into the solution to do well and understand it. Now we have another area that's coming into, let's say, the enterprise, and will come into manufacturing and industry, which is AI that's conversational, right? And AI that essentially, if domain-specific AI understands things, right, then this AI is kind of one way to think about it, is that it understands people, or at least our language. And when you think about a company as a whole and a production floor as a whole, it is really a combination of things and people and conversations that we have. So to truly understand what's going on within a company, you cannot just have one, right? You cannot just judge a company by its production rates, by the health of its equipment, and by its ERP data, financial data. There's a lot of things that go on in between people all the time, that knowledge and so forth, which you alluded to. So that opens up an opportunity to essentially take the whole enterprise, the whole company into account when you think about solutions, making better decisions. When I think about the kind of the architecture of the future of that type of enterprise, it has a number of domain-specific AI applications, as well as kind of a layer of conversational AI taken together. Today, when you think about, who do you ask about what is happening in the company in terms of the business, in terms of how likely are you to produce something well as what is the morale of your team, right? That's one of the executives, right? Probably like a VP of manufacturing, or somebody who's kind of, who's most in tune with what's happening within that part of the organization. And it takes a lot of judgment. With an application like GPT, you can actually have the ability to ask those questions, and in some cases, a lot more effectively to aid that executive, right? And in answering these business questions, and to provide those answers a lot quicker and with a lot more truth, right? Assuming that they're accurate. And also at the same time, to connect that insight to the various insights coming out of domain-specific AI applications. So you kind of have a combination, I believe, will emerge of both GPT type applications as well as domain specific applications working in tandem. And now it's really just a matter of, what does the interface look like? What do the connections look like? What does the data look like? And so forth. And this is where all that data that you mentioned around, whether it's work orders or, knowledge by certain people, or some things that we might have written down somewhere, but we never look at, this is where they become extremely valuable, because that is the kind of the wealth of data and expertise that the company has that we don't really regard today, for the large part because we just don't have access to it. So I think that's really the future of it. The other piece, if I may, is that conversations are a lot more natural for us, for people. And if you can have a conversation that's beyond kind of the rubbish chatbots that were around, up until a year ago or a year and a half ago, you can elevate it to a level that's actually insightful. Now you can have a true interface that's not just about talking about commands or ask from Alexa, right? It's about, what is it that is blocking my production this year? What is it that I need to change within my maintenance or reliability strategy in order to account for this type of cost reduction initiative? In the future, you can actually get intelligent answers, provided that AI applications as well as data sources are properly connected and can feed into that. That opens up a whole new set of opportunities, right? It's almost like having a whole different management executive team that is helping you and advising you on an ongoing basis. And that's what I would call, when we talk about AI co-pilots, this is enterprise level AI co-piloting, right? So it can drive executive decisions. So that's at the high level in the way I kind of think about the future of this.
Okay. Okay. Yeah, very interesting. So you have, on the one hand, access to information sources that previously were too cumbersome to really access it in volume. And then you also have this new interface that allows people that otherwise might really struggle to make sense of information to actually access it in a way that works for a normal business person. Even a normal engineer, I suppose, would sometimes appreciate something other than a graph too, Okay, interesting. So there seem to be also some unique challenges around that, right? So there's integration challenges, the kind of new data sets. There might be some privacy challenges if you have a machine that's listening in on conversations, and then you have to, when should it ignore something and when should it call the police and so forth. So there might be some issues there. There's probably some IP related topics. Anytime you start moving into new data sets, you have to kind of figure out what a company is comfortable with, especially if it means that they're moving information to the cloud to be processed somewhere off premise. If you look at this, are there already some low-hanging fruit where you say in the next 12 months, Augury is already going to be using this new technology to be making some impact, maybe not the grand vision, but some impact? And then what do you see as a realistic timeline for addressing some of these other challenges that adhere to a new technology?
Yeah, I think we definitely need to, some of those things that you mentioned are challenges that need to be resolved. They have been resolved in similar situations in the past rather quickly. If you think about the evolution of closed software, to open source, a lot of things happened in that evolution, but rather quick amount of time, companies have figured out how to use those applications effectively. What should be the rules and regulations around them, how do we share data and so forth. And I think this will happen here. I've seen already a lot of thinking around how that would happen, both from the users and the actual enterprises, the companies, but also from the providers of large models and how to segregate, how to make sure that the data is fair and stays private and so forth. But there's a lot of challenges there to still to resolve. We take obviously a cautious approach to this in terms of data, protecting our customers' data, making sure we're adhere to what we promise always, and the security standards that we set for ourselves. But we are already in the process of integrating some of these technologies into our product. And the way we approach it is very similar to how we approach the kind of domain-specific AI applications that we have, right? It took some time for our machine health AI capabilities to become as accurate as they are, for reliability people in the plant to actually rely on it day to day, and to even issue automatic work orders once there's an Augury alert, right? Without any review, because there's a high level of trust. But to do that, we had to review those alerts for a number of years, and to make sure that we kind of create that last mile of accuracy with our own service people and our own experts to kind of hold it to a very high standard to make sure the machines don't fail. The same approach applies here. If we're integrating GPT type application into, let's say, our customer service, and that provides recommendations to the customer, in the beginning, we will make sure that we review it until we're comfortable with it being accurate enough and useful enough for our users. And so we always put, it's a hybrid intelligence application. We always put a person in between in order to make sure that standard is there and that the quality is high. And then once it is, then we can start releasing that into direct interaction with our customers. So the applications that we have and will have for it, they range between it really improving and making sure that we service our customers faster, helping them answer both questions. Just to give you an example, and we have a lot of conversations and interactions happening within our product. Once we provide a recommendation, users ask, well, should I fix this machine now or later? What's the best strategy to approach it? Is this a systemic issue? So we have a team of experts that help kind of go dive deeper and look at strategy around machine health. And obviously the same happens on the process engineering side. So instead of recreating those conversations through text every time, you can use a GPT type application to essentially pre-populate a lot of that information for our users. And, internally, it's already working rather well because those large language models do include quite a lot of information around reliability and engineering and so forth. So they're rather accurate in what the responses would be. They're just not always specific enough. So we can adjust from there. The other piece is that, I mentioned in the future, you can kind of ask an application, well, what should I do in my factory, right? Or what should be kind of the impact of a certain business decision? and you can potentially get a natural language response back. And so that is another area that we're pursuing within our product to help navigate them better, but also to understand kind of what the interaction looks like beyond the screen and the graph, right? Our users, thousands of them, right? They have a lot of different questions they would like to ask if they had the chance, right? And I think that will also expand the type of functionality that we'll provide to them in the future by kind of having some of these answers on these questions come up. And some of these answers, we'll see a lot more use cases of the kind that users would have with our product. So this is where we're going with this on the customer facing side, and also internally improving some of our processes, whether it's sales or marketing or engineering or product work. There's a lot of interaction going on with GPT applications, and we're already seeing a lot of really, really good results. You just need to kind of learn how to use it to your advantage and how to augment your role with this type of tool.
Yeah, great. No, it sounds like a very pragmatic approach. It basically start fast, but roll out conservatively. Your customers expect a 99% reliability here, right? Artem, I know you have to jump on your next call soon, so let me just kind of open up the last question and say, what have we not touched on yet that you think is important for folks to understand?
Well, I think that you started with that question of what is the approach to building AI applications, and do I just take my data, right, and figure out what to do with it? Do I, try to build a solution for a specific thing? And I think I want to drive that home again, that it is, there's an opportunity to really think anew about how we structure manufacturing teams, how we structure the different functions within manufacturing, and how we create collaboration between those. And the reason I'm saying that is not just because now we have, these AI capabilities and these types of insights. It's important because this is the way you really unlock innovation in manufacturing industry, or in any industry for that matter, right? It's about diversity and collaboration. And we are enabling some of the infrastructure for that diversity and collaboration to actually merge. Because, once you have these types of insights, well, you have to actually collaborate on them to make better, higher order decisions. But I think we're just getting started. And when you think about industry and manufacturing specifically, there's such a kind of ripe, fertile ground for innovation going forward. And maybe we're at like 1 or 2% of the type of wave of innovation where we have. And a lot of people, I believe, based on that, will choose to go into this industry, this profession in the future. Geopolitical kind of movements aside, there's a lot to build, for humanity. And that's really exciting for me, that the level of innovation that's going to happen in the next few years. And obviously GPT and the new technologies around AI are going to play a huge role with it.
Yeah, great. I tell people why I'm in this space, I think similarly to you, right, is that you look out over the next 20, 30 years and you can think, I could spend the rest of my career here and life is going to stay exciting, right? Just at the cusp, and it's already getting pretty complex. Well, folks listening, this is Augury, AUGURY.com. And Artem, thank you so much for taking the time to speak with us today.
Thanks for having me. Thank you.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.